Hello dear student, welcome to new session of current electricity. It's your third lecture. In this lecture we'll discuss what actually resistor is, how we'll get the value of resistor which is called resistance through their different color coding. So first of all, my dear student, what actually resistor is? So write down very first topic, what is resistor? What is resistor? So resistor is nothing but an electronic device. Resistor is nothing but an electronic device. Write down, resistor is nothing but an electronic device which is made up of carbon. So resistor, basically resistor, it is an electric device. It is an electric device which is made up of carbon. Basically, my dear student, resistor is made up of carbon. And see, any resistor carry two ends. Any resistor carry two ends. Any resistor carry two ends. So my dear student, basically every resistor carry two different ends. And see, basically in resistor, different types of colors bands are present. So I'll write here, in resistors, different types of color bands are present. Different types of color bands are present. With the help of that color bands, we'll find the value of resistance of that resistor. So I'll write, with the help of those color bands, we will get the value of resistance. We will get the value of resistance. So remember, very first thing is, resistor is basically nothing but an electric device which is made up of, my dear student, carbon. Any resistor carry two different ends. It was look like this. This type of cylindrical structure is called resistor. And this resistor carry two different ends. In resistors, my dear student, different color bands are present. With the help of these different color bands, we'll get the value of resistance of that resistor with the help of table. That basically table is give you the information of value of resistance of that resistor. That's why the topic is color coding of resistor. Now see, my dear student, every resistor carry maximum 4 bands, not more than 4 color bands and not less than 3 color bands. So I'll write, every resistor carry maximum 4 bands and minimum 3 bands on it. With the help of these color bands, we will get the value of resistance. With the help of their color bands, we'll get the value of resistance. So my dear student, first thing remember, any resistor carry 4 color bands maximum and 3 color bands minimum. So at least 3 color bands are present, at most 4 color bands are present. With the help of color, we will give the value of resistance, or we can say we'll find the value of resistance of that resistor. So see, my dear student, this is our resistor. This is made up of carbon. carry two different ends. In this register, 4 color bands maximum, 3 color bands minimum is present. Like this, first color band, second color band, third color band and fourth color band. Sometime the fourth band is missing. Remember, sometime the fourth band is missing. I'll write here, in some cases fourth band from resistor is missing. Remember, sometime fourth band from the register, fourth color band from the register is missing, my dear student. Now see, actually the calculation of register is always starting from leftmost end. So I'll write the value of register. The value of register is always started from leftmost band. So always remember, the value of resistance can be calculated from leftmost end. So see, my dear student, this first band is said to be digit 1. First band is said to be digit 1. Second band is said to be digit 2. Second band is said to be digit 2. Third band represents multiplier. And the fourth band is considered to be tolerance value. So remember, any resistor, see, resistor is made up of carbon, first thing. Second thing, the value of resistor is found by color bands which is present on resistor. Third thing, always maximum 4 bands and minimum 3 bands are present on resistor. Next thing is, we have to calculate the value of resistance of resistor always from leftmost end. So first band from leftmost is digit 1, second is digit 2, third is multiplier and fourth is tolerance value. And one more thing, my dear student, tolerance value is always calculated in percent. I'll write here, tolerance value of resistor is always calculated in percentage. Remember this thing, the tolerance value is always calculated in percentage. Dear students. So check it out, how we'll find the value of resistance through color coding. Remember, digit 1, digit 2, multiplier and fourth is your tolerance value. So for finding the value of resistance, you have to learn a table. See what actually table is. So there is a shortcut to learn a table. It is, I'll explain you how we'll give the value of resistance. So dear student, there is a table in which the codes of color is given. To get the answer of resistance, you have to learn that table. So the table is how it forms. There is a shortcut. See, in table we have 3 columns. First is color, second is digit, third is multiplier value and fourth is tolerance. So see, the color coding is like this: BB Roy, Great Britain. BB Roy, Great Britain has very good wife, gold, silver, no color. Gold, silver, no color. So this is basically the trick to learn the table. It is B Roy. See my dear student, you have to follow only capital, or we can say bold letter. Just to complete the sentence, we'll put some words additional. So B Roy, great. In great only G is in capital, so we'll consider only G. B Roy, Great Britain. In Britain only B is capital, has no capital word is there, so remove this. V, very means V, good means G, wife means W, gold, silver and no color. You have to learn this as it is. So B Roy, Great Britain has very good wife, gold, silver and no color. Now see my dear student, this B stands for black. This B stands for black. Next B stands for brown. Next B stands for brown. This R, see all the three letters are bold, so every letter carry a word in color combination. So Roy, so R for red, O for orange, Y for yellow, so I'll write yellow. Next great, in great G is green. Next B is for blue. Next has no capital letter is there. V is for violet. Next G is for gray. Next W is for white. W is for white. So my dear student, remember this is how you have to learn the table. B Roy, Great Britain has very good wife. B Roy, Great Britain has very good wife. B Roy, Great Britain has very good wife. So first B is black, second B is brown, R for red, O for orange, Y for yellow, G for green, B for blue, has no capital word is there, V for violet, G for grey and W for white. Then after gold, silver and no color, you have to learn it as it is. Here space is not there. After completing this, I'll write gold, silver and after then we'll write no color. So try to copy this thing my dear student. So blue, this is how we'll color code, we'll give the color code of register. Blue, the shortcut is B Roy, Great Britain has very good wife, gold, silver and no color. First B is for black, second B is for brown, third is red, orange, yellow, green, blue, violet, grey, white, then gold, then silver, then no color. After white, we have to write gold, then we have to write silver, then we have to write silver and at last no color is there. No color is there. Remember, this is how we'll prepare the table. Now, moving forward, so this is basically color. Now we have to start writing digit. So start writing digit with 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Digit for gold is nothing, digit for silver is nothing and digit for no color is nothing my dear students. So the digit is from black to gold, black to white. The digit of black is 0, the digit of brown is 1, the digit of red is 2, digit of orange 3, digit of yellow 4, digit of green 5, digit of blue 6, digit of violet 7, digit of grey 8, digit of white 9, gold no digit, silver no digit, no color no digit. Moving forward, multiplier. So the digit becomes power in case of multiplier. So it is 0 raised power 10 raised power 0, 10 raised power 1, 10 raised power 2, 10 raised power 3, 10 raised power 4, 10 raised power 5, 10 raised power 6, 10 raised power 7, 10 raised power 8, 10 raised power 9. Means the multiplier of black is 10 raised power 0, brown is 10 raised power 1, red is 10 raised power 2, orange it is 10 raised power 3, yellow it is 10 raised power 4, green it is 10 raised power 5, blue it is 10 raised power 6, 10 raised power 7 is for violet, 10 raised power 8 is for grey, 10 raised power 9 is for white. Gold, silver, no color carry no multiplier, my dear student. Remember, gold, silver and no color carry 0 multiplier. No multiplier is for gold, silver and no color. Now moving forward, calculation of tolerance. So tolerance can be calculated in percentage. Black have no tolerance value, brown has no tolerance value, red has no tolerance value, orange has no tolerance value, yellow no tolerance, green no tolerance, blue no tolerance, violet no tolerance, grey no tolerance, white no tolerance. Tolerance value is only for gold. It is plus minus 5%. Tolerance value of gold is plus minus 5%. Similarly, tolerance value of silver is again plus minus 10%. So tolerance value of silver is plus minus 10%, and if no color is there, no color means if fourth band is missing, my dear student. Remember, I'll tell you already that any register carry 3 bands minimum and 4 bands maximum. In some cases, fourth band is missing, which is basically tolerance value, tolerance band. So sometime tolerance band is missing. In that case, no color is there. So if fourth band is missing, then we'll take tolerance to be plus minus 20%. So I'll write in form of note, if fourth band is missing, if fourth band is missing, then we have to take tolerance to be plus minus 20%. Then we have to take tolerance to be plus minus 20%. We have to take tolerance to be plus minus 20%. So this is basically the color coding, how we'll proceed with the band of register. I hope you all understand this thing. Remember the table, and the trick to learn the table is here. B.B. Roy, Great Britain, has very good wife, gold, silver, no color. Remember, if fourth band is missing, then we have to write the value of tolerance to be plus minus 20%. Plus minus 20%. Moving forward, my dear student, let's check it out how we have to give the value of register by its color coding. So check it out. See, let's suppose we have a register in which 4 bands is present. Let's suppose we have a register in which 4 bands is present like this. This is a register. 4 bands is present, 1, 2, 3 and 4. Let's suppose first band is of color of green, second band is of color of orange, third band is of color of yellow and fourth band is of color of gold. So 4 bands is there and we have to give the value of resistance. Now see, first band is considered to be digit 1, second band is considered to be digit 2, third band is nothing but multiplier and fourth band is nothing but tolerance. So digit 1, check it out. The digit of green is 5. So write down 5. Next is orange. Second band is of color of orange, my dear student, and we know that second band represents for digit. So check it out, the digit of orange, it is 3. So 5, 3. Next, third band is of color of yellow and third band represents multiplier. So multiply and yellow. So yellow is 10 raised power 4. Next is tolerance. Tolerance can be calculated always in percent and the color is gold and the tolerance value of gold is plus minus 5%. So write down plus minus 5%. This is the value of resistance which is given with color coding. Very easy to solve these types of question, my dear student. So moving forward, let's check it out one more question so that it will be clear for you. Let's suppose we have register in which 3 bands is present. Now 4th band is missing. So how to get the answer? This is a carbon register. First band, second band, third band, fourth band is missing. Let's suppose this color is of red, this band is of color of, let's suppose, green, this band is of color of, let's suppose, blue, and fourth band is missing. So we have to write the value of register. See, first band represents digit 1, second band represents digit 2, third band represents multiplier, and we know that if fourth band is missing, then tolerance will be considered to be plus minus 20%. So check it out. Digit 1, red is 2, so 2. Next is green, so digit 2, green is of 5, so 5. Multiply blue, the value of multiplier of blue is 10 raised power 6, so 10 raised power 6 and plus minus 20%. This is the value of resistance with the help of color code. I hope you all understand. Remember, if fourth band is missing, then you have to take tolerance to be plus minus 20%. Now see, my dear students, sometime the question asks in reverse method, as in question they say, if the resistance of register is, let's suppose 23 into 10 raised power 6 plus minus 10%, draw the color code. The value of resistance is, write down the question, the value of resistance is 23 into 10 raised power 6 plus minus 10%, draw the color bands of the register. So see, my dear student, we have to draw its color bands. Color bands will be like this: 1, 2, 3 and 4th. See, tolerance is plus minus 10. It means fourth band must be of silver color. Now come to digit 1, 2. 2 means red, so first band must be in color of red. Second is basically digit 2, so 3. So 3 must be orange, so it is orange. And third is multiplier, so 10 raised power 6. 10 raised power 6 is for blue, so third band is of blue color. So this is how we'll solve the value, we'll get the value of register with the help of color coding. Remember, this is the table which you have to learn to solve these types of questions. So I hope you all understand how to find the value of resistance of the register through color coding. Now moving forward, my dear student, write down a question. It is calculate the resistivity. Write down the question. Calculate the resistivity of a material, of a wire. Calculate the resistivity of a material of a wire 10 meter long, 0.4 millimeter in diameter, 0.4 millimeter in diameter, and having a resistance of 2 ohm, and having a resistance of 2 ohm, and having a resistance of 2 ohm, and having a resistance of 2 ohms. So see my dear student, they are asking for you have to find its resistivity. So resistivity means you have to find the value of rho. There is a wire whose length is given and whose diameter is also given. Length is 10 meter and its diameter is 0.4 mm. So we know that if diameter is given, then radius becomes its half, so 0.2 mm. Convert it into meter, so 0.2 into 10 raised power 3 meter. Length is given, we have to find its resistivity. Resistance is also there and the value of resistance is 2 ohm. So just calculate the value of resistivity. As we know relation, R is equals to rho L by A. So R into A by L is equals to rho. So rho becomes equals to R is to A, that is area. So area must be pi R square. So pi into R square, it is 0.2 into 10 raised power 3 and square divided by length is 10. So rho becomes equals to 2 into 3.14 into 0.2 into 10 raised power minus 3 into 0.2 into 10 raised power minus 3 divided by 10. So find the value of resistivity, dear student. The value becomes 2.5 into 10 raised power minus 8. 2.5 into 10 raised power minus 8 ohm meter. After solving this, you will get the answer. It is 2.5 into 10 raised power minus 8 ohm meter. Write down next question. Next question says that a copper wire of radius 0.1 mm, a copper wire of radius 0.1 mm, a copper wire of radius 0.1 mm and resistance 10 raised power 3 ohm 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 is connected across a power supply of 20 volt, is connected across a power supply of 20 volt, full stop. First part of the question is how many electrons are transferred per second. How many electrons are transferred per second between the supply and the wire at one end and the wire at one end and the wire at one end and the wire at one end, question mark. Second part, write down the current density in the wire. Write down the current density in the wire. Write down the current density in the wire. I am repeating once again. A copper wire of radius 0.1 mm and resistance 10 raised power 3 ohm. So radius of wire is given. Radius is 0.2 mm, I guess. It is 0.1 mm. So 0.1 mm. So if I will convert it into meter, it is 0.1 into 10 raised power minus 3 meter. So radius is given. Now resistance is also given. It is 10 raised power 3 ohm. They are asking for power is also, means potential is also given. See, potential is nothing but 20 volt. So V is given. So V is 20 volt. In first question they are asking for number of electron. Second they are asking for current density. So we know that I is equals to Q by T. Q can be write as NE. So we'll write it as I is equals to NE by T. So I into T by E is equals to N. So first, for finding number of electron, we have to find the value of current. So V is equals to IR. So I is equals to V by R. V is 20 and R is 10 raised power 3. So I becomes equals to 10 raised power 3 means beta 3 times 0. After solving this, you will get 0.02 ampere. So this is the value of current. Put it here. Time is there. So they are asking in 1 minute. So 1 minute is time. So what we'll get? N is equals to 0.02 multiplied by 1 divided by E. So E is nothing but 1.6 into 10 raised power minus 19. So after solving this, you will get the value of N. So the value of N is 1.25 into 10 raised power 17. So 1.25 into 10 raised power 17 is number of electron. Second part, they are asking for current density, and we know that the formula of current density is J is equals to I by A. I is current. Current is given. It is 0.02. Area must be pi r square. So J becomes equals to 0.02 divided by pi means 3.14 multiply R. Radius, it is 0.1 into 10 raised power minus 3 and its square. So solve this relation, you will get 6.37 into 10 raised power 5. 6.37 into 10 raised power 5 ampere meter square, because this is the SI unit of current density. I hope you all understand this question. For finding number of electrons, first of all we have to find current. Current must be V by R. So we'll put the value of I. We'll get the value of number of electron, because we know that Q is equals to NE. So N is equals to I into T by E. After getting E, N, the value of N, we'll solve to next part. J is equals to I by A, that is current density is equals to current per unit area. Moving forward, write down next question, dear student. So the question is, find the resistivity of a conductor. 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 Find the resistivity of a conductor in which a current density, find the resistivity of conductor. So they are asking for finding the resistivity. We have to find the value of rho. The resistivity of conductor in which a current density 2.5 ampere per meter square, 2.5 ampere per meter square is found to exist, when an electric field of 15 volt meter inverse, 15 volt meter inverse is applied on it, I'm repeating once again. Find the resistivity of a conductor in which a current density of 2.5 ampere per meter square is found to exist when an electric field of 15 volt meter inverse is applied on it. 15 volt meter inverse is applied on it. Now see, my dear student, we have to find the resistivity. So first of all, find the resistivity. So we can write rho is equals to, we know that R is equals to rho L by A. So R into A by L is equals to rho. This thing will be happened. Now see, V is equals to IR. So instead of R, we can write V by I. So what we'll get? We'll get V by I into A by L is equals to rho. Now we know that electric field is nothing but V by L, and electric field is given. So V by L can be write as E. So we'll write E into A divided by I is equals to rho. Now see my dear student, A is also not given. A is also not given. A is also not given. So how to find this thing? I by A. Okay, current density is there. So J is equals to current per unit area. But here I by A, so we'll write A by I is equals to 1 by J. So rho is equals to E by J. So rho is equals to electric field is 15 and J is 2.5. So find the value of resistivity. After solving this, you'll get answer as 6 ohm meter. This is the answer of resistivity. Quite interesting question. We have to convert 2-3 times the formula. Moving forward, my dear student, write down next question. Calculate the electrical conductivity. Now they are asking for conductivity. Calculate the electrical conductivity. Calculate the electrical conductivity of the material. Calculate the electrical conductivity. Calculate the electrical conductivity of the material. Calculate the electrical conductivity of the material. Calculate the electrical conductivity of the material. Calculate the electrical conductivity of the material of a conductor. Calculate the electrical conductivity of the material of a conductor of length 3 meter. So length of conductor is given, it is 3 meter. L is equals to 3 meter. L is equals to 3 meter. Area of cross section 0.02 mm square. Area of cross section 0.02 mm square. We have to find its conductivity, and we know that conductivity is reciprocal of resistivity, and resistivity is nothing but, we know that relation, it is R is equals to rho L by A. So R into A by L is equals to rho. So area of cross section is given having a resistance of 2 ohm. Having resistance of 2 ohm. Having resistance of 2 ohm. So resistance is also given. Now see, area of cross section is 0.02 mm square. So it's square, my dear students. So converting into meter, it is multiply by 10 raised power minus 3, but it is square. So 10 raised power minus 6. So area becomes equals to 0.02 mm square. If single meter is there, then it will be 0.02 into 10 raised power minus 3 meter, but it's square. So we'll say 0.02 into 10 raised power minus 6 meter square. So find the value of conductivity, dear student. It will be rho is equals to, sigma is equals to 1 by rho. So sigma is equals to 1 by rho means R into A, and L comes forward upside. Length of conductor is 3, resistance is 2, area must be pi r square. So area is given itself, so why to take value pi r square? So L by 3 by 2 into area is 0.02 into 10 raised power minus 6. So try to calculate this. Try to calculate, my dear student. You will get answer as 75 into 10 raised power 6. 75 into 10 raised power 6 ohm inverse meter inverse. Ohm inverse meter inverse. This is the answer of conductivity. I hope you all understand. These questions are nothing but formula based question, my dear student. You must aware with these types of question as well. Moving forward, write down next question. Write down, dear student. So the question is, calculate the electric field. Calculate the electric field. Calculate the electric field in a copper wire. Calculate the electric field in a copper wire. In a copper wire of cross sectional area. In a copper wire of cross sectional area 2 mm square. calculate the electric field in a copper wire of cross sectional area 2 mm square of cross sectional area 2 mm square. They have to find the value of electric field. They are asking to find the value of electric field of cross sectional area 2 mm square carrying a current of 1 ampere, carrying a current of 1 ampere. Resistivity of copper is 1.7 into 10 raised power minus 8, 1.7 into 10 raised power minus 8 ohm meter square. Calculate the electric current, calculate the electric field in a copper wire of cross sectional area 2 mm square carrying a current of 1 ampere. The resistivity of copper is 1.7 into 10 raised power minus 8 ohm meter. So you have to find the value of electric field. Current is given, area is given, resistivity is given. So we know that E is nothing but V by L. We can also write IR. So E is equals to IR by L. Now see, R can be write as rho L by A. So what we'll get? E is equals to I into, instead of R, we'll write rho L by A into L is already there. L cancelled. So I into rho by A. So electric field is equals to, the value of current is 1.7 into 10 raised power minus 8 divided by 2 mm square. So mm will be converted into meter. It is 2 into 10 raised power minus 6 meter. 2 into 10 raised power minus 6 meter square. So it is 2 into 10 raised power minus 6 meter square. After solving this, you will get your answer, and the answer is 0.85 into 10 raised power minus 2. 0.85 into 10 raised power minus 2. 0.85 into 10 raised power minus 2 voltmeter inverse. This is the value of, dear student, electric field. I hope you all understand each and every numerical. You understand how we'll give the value of register with the help of color coding. So thank you so much, my dear student, connecting with us. In next class, we'll discuss a new topic called mechanism of flow of current in a conductor. Till then, stay happy, stay at your home, study hard, make proper notes, revise it again and again, try a separate notebook for your formulas, numericals. Thank you so much, my dear student. Thank you.